Hello friends, in this video I am going to solve problems on first law of thermodynamics applied to closed system. In this problem, when a system is taken from state A to B in the figure, state A to B in the figure along path ACB, so this is the path along ACB, 84 kilojoules of heat flow into the system and the system does 32 kilojoules of work. How much will be the heat flow into the system along path ADB if the work done is 10 kilojoules? When the system is returned from B to A, if the work done along the curved path, the work done on the system is 21 kilojoules. Does the system absorb or liberate heat? How much of the heat is absorbed or liberated? If UA is 0, that is internal energy at state point A is 0, and UD is 42 kilojoules, that is at state point D, internal energy is 42 kilojoules. Find the heat absorbed in the processes AD and DB. So first let us list the given data. So along the process AB, when the system is taken, then this will be heat interaction Q ACB equal to 84 kilojoules, and that is heat flow that takes place into the system and does work of 32 kilojoules. So W ACB equal to 32 kilojoules, and how much will be the heat that flows into the system along the path ADB if the work done is 10.5 kilojoules. So for that we should find out Q ADB when W ADB is 10.5 kilojoules. When the system is returned from B to A along the curved path, the work done on the system is 21 kilojoules. So W BA is minus 21 kilojoules as there is work done on the system. It is minus 21 kilojoules. And what is the heat that is absorbed or liberated? So what is QBA? It is to be calculated. Now if UA is equal to 0 and UD is 42 kilojoules, what is the heat absorbed along the processes AD and DB? So what is QAD and QDB? So to find out QADB, so QADB equal to final internal energy, that is UB minus initial internal energy UA plus WADB. This is the first law of thermodynamics applied to process ADB. So here we have WADB, that is 10.5 kilojoules. If we calculate UB minus UA, from that we can find out QADB. So to find out the UB minus UA, let us apply first law of thermodynamics to process ACB. So then that becomes Q ACB equal to UB minus UA. So final internal energy that is UB, and initial internal energy UA plus WACB. Here we have QACB, it is 84 equal to UB minus UA plus WACB equal to 32. So then this becomes UB minus UA will be 52 kilojoules. So let us substitute this UB minus UA to this equation. UA is 52 kilojoules. It is 52 plus WAB is 10.5. So this will be 62.5 kilojoules. So this is for QADB. Similarly, to find out the heat that is liberated along the process BA, for that we have let us apply first law of thermodynamics to process BA. So then this becomes QBA equal to it is UA minus UB. Final internal energy is UA and initial internal energy is UB plus WBA. Here we have UB minus UA. So if we write this one in terms of UA minus UB, so if the same equation is written in this form, if it is UA minus UB, this will be minus 52 kilojoules. So then QBA can be calculated with the help of this one. This is minus 52 U minus UB plus WBA is minus 21 kilojoules. It is minus 21 kilojoules. So this QBA will be minus 73 kilojoules. So here it is a negative symbol. So heat is liberated in this process. Then to find out QAD and QDB, so here we have QDB equal to QAD plus QDB. So here QAD equal to UD minus UA plus WAD. Here we have UD and UA, and for WAD we will have like this WADB equal to WAD plus WDB. So work done along the process AD plus work done along the process DB. So here along the process DB is 0, along the process AD will be WADB. So WADB is 10.5 kilojoules. So 10.5 equal to WAD plus WDB is 0. So WAD is 10.5. So let us substitute this term to this equation. Then we'll have QAD equal to UD is 42 minus 0 plus WAD is 10.5, so this will be 52.5 kilojoules. Then we have Q ADB equal to QAD plus QDB. So we have QADB that is 62.5 kilojoules. So it is 62.5 equal to QAD is 52.5 plus QDB. So QDB is 10 kilojoules. So it is about this problem. And in the next problem, we have a piston cylinder machine that contains fluid system which passes through a complete cycle of 4 processes. During a cycle, sum of all heat transfers is minus 170 kilojoules. The system completes 100 cycles per minute. Complete the following table showing the method for each item and compute the net rate of work output in kilowatts. So along the process AB, heat interaction is 0 and W is work done in kilojoules per minute is 22,170, and then delta E has to be calculated. Similarly, for process BC, 21,000 kilojoules per minute of heat is supplied, that will produce 0 kilojoules per minute of work, and delta E has to be calculated. And along the process CD, 2100 kilojoules of heat is liberated, kilojoules per minute of heat is liberated. Then work done is to be calculated when there is 36,600 kilojoules per minute of internal energy is decreased. Then for process DA, we have to calculate Q, W and delta E. So first for process AB, we have QAB equal to delta EAB plus WAB. QAB in this case it is 0, that is equal to delta EAB has to be calculated plus WAB is 2170 kilojoules per minute. So delta EAB is minus 2170 kilojoules per minute. Then in the process BC, that is here, Q BC equal to delta E BC plus W BC. So Q BC is 21,000 kilojoules per minute, that is equal to delta E BC has to be calculated plus WBC is 0. So delta EBC is plus 21,000 kilojoules per minute. So it is 21,000 kilojoules per minute. Similarly, for process CD, we have QCD equal to delta ECD plus WCD. So here QCD is minus 2100 kilojoules per minute, that is equal to delta ECD is once again minus 36,600 kilojoules per minute plus WCD. Here WCD has to be calculated. So WCD will be 34,500 kilojoules per minute. So here in this process there is a sum of all heat transfers is minus 170 kilojoules, and system completes 100 cycles per minute. So the total heat transferred is minus 170 into 100 cycles per minute. So that becomes Q total will be minus 170. There will be 100 cycles per minute. So this will be minus 17,000 kilojoules per minute. So Q total is given by QAB plus QBC plus QCD plus QDA. So Q total is minus 17,000 kilojoules per minute equal to QAB. It is 0 plus QBC is 21,000 kilojoules per minute. Then QCD is minus 2,100 kilojoules per minute plus QDA. So QDA equal to minus 35,900 kilojoules per minute of this one QDA. Then we have cyclic integral of any property is 0. So cyclic integral of delta E is 0. So that means delta E AB plus delta E BC plus delta E CD plus delta E DA, delta E DA equal to 0. Then delta E AB will be minus 2170. Then plus delta E BC is 21,000 kilojoules per minute. It is 21,000 plus delta E CD. Delta E CD will be minus 6,600 plus delta E dA equal to 0. So then delta E dA will be 17,770 kilojoules per minute. So after calculating delta E dA and Q dA, we can calculate WdA. So to find out WdA, let us have the first law of thermodynamics to process dA. So Q dA equal to delta E dA plus W dA. So Q dA is minus 35,900 equal to delta E dA is 17,770 plus W dA. So W dA will be minus 53,670 kilojoules per minute. Then we have for a cyclic process sigma Q cycle will be sigma W cycle. So this will be 17,000 kilojoules minus 17,000 kilojoules per minute. So if we divide this one by 60, so it is minus 17,000 divided by 60 will give the answer in kilojoules per second. So a minute has 60 seconds, so divided by 60 will give the answer in kilojoules per second, that is in kilowatt. So it is minus 283.3 kilowatt. So that is calculated now.